The single most important feature for many apps is the user authentication system. If you don't have a good way to sign in users and observe their data, it's hard to build out anything else. In today's video, we'll implement Google OAuth via Firebase in an Angular app. In addition, we'll save custom information about the user in the Firestore database, and we'll implement full-stack security on both the front end and the back end. So by the end of this video, you should have a solid auth system that you can build on. If you're new here, like and subscribe, and you can find the full source code on Fireship.io. And I'd like to quickly point out that this is the first episode with the new Fireship.io channel name, but this video is actually a revision of episode 55 from Angular Firebase. Over the next few months, I'll be revising and updating a lot of that content, so if there's anything you want to see me revisit, let me know in the comments. To get started with this lesson, you'll need to have an Angular app with Angular Fire and Firebase installed. You can find full instructions for that on the main lesson page. First, we'll go into our Firebase project, and under the Authentication tab, we'll enable the Google SignIn method. From there, we'll go ahead and enable Firestore, and for now we'll leave the security rules unlocked, but we'll circle back around to this at the end of the video to secure the backend. When we sign in a user with Firebase, it's going to create this authentication record, but it's very limited and we can't easily customize it. The important thing that it gives us is a unique user ID, which we can use to model relational data in Firestore. For example, you might have a has-one relationship where a user has an account, and we can easily model that in the database by just giving the document itself the same user ID as the authentication record. Now we'll jump into Angular and write some code that can read, write, and react to this data in real time. Your user authentication logic and state is something that you'll be managing globally, so you'll want to have it organized as an Angular service. So we can go ahead and generate it with the Angular CLI by running ng-generate service. And I'm putting it inside of a services directory. Now, before we get into the service itself, there's one optional thing you can do here, and that's model your data as a TypeScript interface. If you have a lot of complex custom data on the user document, it helps to be very explicit about it. So every property that can exist on the user document will also exist on this TypeScript interface, preventing bugs that send invalid data to the database. Now we can jump into our auth service, and we'll start by importing a few things first. We'll use the Angular router to redirect users after they sign out. Then Angular Fire provides us with services that we can use to interact with Firebase Auth and Firestore. And lastly, we have a couple of things here from RxJS that we'll use for the control flow on the user auth observable. And optionally, you can also import the user interface that we defined in the last step. This service has one piece of stateful data that we can share between all of our components, and that is the database record itself, the user document. It's defined as an observable because it can change in real time, for example, when the user signs in or signs out. Right now, you'll see that it's typed to any, but if you're using the user interface, you'll want to type it to the user. The next thing we'll do is inject our dependencies in the constructor. So we have Angular Fire Auth, Firestore, and the router. Now we'll want to define our actual user observable as soon as possible, which would be in the constructor of the service. So we'll start by making it equal to the Angular Fire Auth state. And if you're not using any custom data, you can just stop right there because that'll give you the user record that you have in the Authentication tab. But in most cases, you're going to want more data than that, so we'll use the auth state to switch to an observable of this database record. We can do this with the RxJS switch map operator, which allows us to listen to the user that's emitted from this auth state observable, and then switch to a different observable of the database record. So we'll have access to the user inside of switch map, which is either going to be the user authentication record or null. So if the user is defined, then we'll go ahead and reach out to Firestore by calling afsdoc, and then point to the document with the matching user ID. And lastly, we call value changes to convert it to an observable. If the user is not defined, then we just want to return an observable of null from switchmap. This could be some kind of other default value, but it allows us to tell when the user is not logged in. So now we have a user record in Firestore that we can react to based on the authentication state. But in order for this to be useful, we need a way for the user to first log in. So I'll create an async function here called Google SignIn, because most of the Firebase API is actually promise-based. So we make a reference to the Google Auth provider, and then we pass that in to sign in with popup, and that will trigger the actual popup modal where the user logs into their Google account. That's going to resolve with the credential of that user, which we can then use to update user data in Firestore. We'll implement this method next, but I'd like to point out that you can also update or create the user record in Firestore with a cloud function. We're not going to cover it in this video, but just know that that's an option. The next thing we'll do is really quickly implement a signout method. This will also be an async function, and it will just await the Angular Fire auth signout and then navigate back to the root page. So currently this update user data method is just taking information from the Angular Fire auth state and then mirroring it on the Firestore document. But this is the point where you could add any kind of custom data that you want. So we'll take the user from the credential that we get after the pop-up sign-in, and we'll point to the document in the database with that user ID. From there, we'll define the data payload that we want to save. Then we'll call set on the user reference and pass it this data. When you call set, it's destructive, so if there's an existing document in this place, it will erase all that data and replace it. That's usually not the behavior that you want for a returning user, so you can avoid it by adding this merge true option, which will only change the properties that change in the data payload. In other words, the existing data will not be erased. If you want to get a little fancy with your JavaScript, you could actually destructure all these properties in the function argument. Basically, we're just taking the properties on the object and automatically assigning them as variables inside the scope of this function. And thank you TypeScript for telling me exactly what's wrong as I refactor. That takes care of all the hard stuff. Now we can go into any component and just inject this auth service in the constructor and share its data and functionality. I want to bind this to the HTML, so I'm making it a public property in the constructor. Now we can switch over to the HTML and just write some logic using Angular's directives. Our user is an observable, which means we need to subscribe to it. In Angular, we can do this with the async pipe, which will automatically manage the subscription for us. Then we can write as user, which sets a template variable for the user document information that we can use directly here in the template. And if that value happens to be null, then we're going to display a login button. For debugging purposes, we'll use the JSON pipe to show the user object directly in the view. And this is only available to the logged in user, so we'll also add a sign out button here as well. And that's as simple as binding to the click event and then calling auth sign out. The next thing we'll do is define that login template, which we can do with an ng template tag and give it a name of login. Then we create another button inside of here, and this time bind the click event to auth Google sign in. Now we can finally check out our app in the browser, and you'll see if we click the Login with Google button, we should get this pop-up window, and once we sign in, it will show the user information in the view automatically. Now at this point I have a couple of extra tips for you. If you're using Angular material, you'll want to check out the ngxauth Firebase UI library, which has a bunch of pre-built components that can help you get things done faster. Another thing you might notice is that this JSON user object is really hard to read. Another little pro tip that comes from bman on Twitter is to wrap your JSON pipe in a pre-tag. It will put every object property on its own line, which is much easier to read, especially if you have a big object. So now we have a working user authentication system in place, but now you'll probably want to define some routes that can only be accessed by a logged in user, for example, the user dashboard. Angular provides a really elegant solution to composing your router logic. First, I'm going to define a component called supersecret that should only be accessed by logged in users, and then I'll add it to the secret route in the router config. Now back in the app, you can see that we're not logged in, and if we click the secret button, it still navigates to the secret route. We're going to generate another thing called a guard, which is actually just an Angular service that has some special methods that we can implement to control the router logic. The most common one is canActivate, which is a method that will return a boolean or an observable of a boolean, and if it's true, it will activate the route. If it's false, it will not. We already have the user observable from our auth service, it's just not in a boolean format yet. So we can go ahead and inject the auth service in the guard constructor. Then we'll return the user observable from the canActivate method, but we'll need to first pipe in a few RxJS operators. The first one is take1, which will automatically complete the observable after the first value is emitted, because we don't need to keep it running after the route has been blocked. Then we'll use map to map the object to a boolean, and we can do that with just a double bang because we have an observable of null if the user is not logged in. And lastly, if the user is not logged in, you probably want to navigate them to a login page or somewhere else. In our case, we'll just go ahead and console log access denied. So that's all there is to it, and now we can use this on any route that requires this logic. We can tell Angular where to apply it by going back to our router, and then using the canActivate property and adding it to the array. Now if we go back to the app and try to navigate to this route, it's going to console log access denied, but more importantly, it's not going to instantiate that component. So that gives us some front-end logic for the user experience, but it doesn't give us full stack security. Someone could still grab our Firebase credentials and modify other user records. Those credentials have to be in the client-side code, so in order to secure the app, we need a rule that will only allow authenticated users to modify documents with the corresponding user ID. So we'll go down here to the user's path and then add a wildcard for the user ID, and we'll say allow write if the isOwner function resolves to true. It's optional to write this as a function in Firestore, but I like to write my rules as functions because they tend to be a lot more readable, especially when you have a lot of complex document relationships. So we can easily implement this by saying request auth UID equals the wildcard user ID. In other words, if you're not logged into the correct account, you can't read or write the user document. Now, one thing you have to be careful of is with Firebase rules, it's going to look for the first allow rule. Currently, our rules will not work because we're still allowing reads and writes at the global level. Firebase will see that first and allow the operation. So I recommend doing if false at the global level just so everything is locked down by default. So now we have a fully secure Angular Firebase authentication system. It can scale to millions of users, it reacts to changes in real time, and it can handle any kind of custom data we want to throw at it. I'm going to go ahead and wrap things up there, but I'm considering doing this same video with other frameworks, like maybe React, Vue, and Flutter, just so you can compare the differences at a very fundamental and practical level. If you want to see that happen, let me know in the comments so I can prioritize it. Thanks for watching, and I will talk to you soon.